Every day we visit countless websites and exchange numerous emails. But what if one of those emails contains malicious code? We often click on links in emails without giving it much thought. And if clicking on one of those links leads us to a malicious site without our knowledge, it can cause serious trouble. This is where cross-site scripting, XSS, comes into play. Technically, it's just a hyperlink, but when clicked, it can perform malicious actions or engage in fraudulent behavior, which is obviously bad. Hyperlinks are meant to fetch documents from either the same server or a different one, which is perfectly fine when used correctly. However, if the server providing the document is compromised or the document itself is malicious, it becomes a problem. Let me introduce you to one type of malware that malicious hackers often use. It typically looks something like this. They create a document on their own web server and embed malicious code within it. So, after creating that document with malicious code, the next step is to craft a hyperlink to fetch that document and embed it in an email, enticing people to click on it. This technique is what we call social engineering hacking. It involves using various tactics to manipulate individuals into divulging information or performing desired actions. Once someone clicks on the hyperlink in the email, their browser will connect to the cracker's server and download the web page containing the malicious code. Subsequently, the browser will execute that code. The operation principle of the malicious code is straightforward. Since the image file's location is set to nothing, an error will occur because such a file doesn't exist, triggering the onerror event. When this event is triggered, it will send your session ID to the cracker's server, allowing them to access the website you're logged into, masquerading as you. This is what we call session hijacking. In reality, there doesn't need to be a getsessionid.php page. Only the correct port needs to be targeted. Let's say there's such malicious code. The crackers would likely have their server, 172.7.0.2, listening on port 31337. They often use tools like netcat to open ports. Most XSS code structures consist of two main parts, one that triggers the malicious code and another that activates the switch to trigger it, like turning on a car's ignition. The part where we intentionally specify a non-existent file in the img tag is where we turn the ignition, and the onerror part is where the malicious code is executed. Reflective XSS techniques typically involve sending out emails to a large number of users, hoping that some will click on the malicious link. Therefore, defenses against this can be surprisingly simple, such as using whitelist-based spam filters or refraining from clicking on links in emails from unknown sources. However, people often don't utilize robust whitelists due to concerns about missing important emails and the inconvenience they might cause. If someone does click on a malicious link and lands on a fake website created by the hacker, it's practically impossible to distinguish it from the real one just by looking at it. Hence, not clicking on it in the first place is the best defense mechanism. Even if the session ID is stolen and transmitted, the victim wouldn't be aware of anything happening. In the worst-case scenario, the hacker could hijack the victim's entire browser, stealing any IDs or passwords entered there, or even taking screenshots of the screen. It's like remotely controlling someone else's browser functionalities. This is possible because when you click on a link from an unknown source, your browser receives a payload of JavaScript-based hacking code from the hacker's server. Such hacking tools actually exist, like Beef, a well-known component of the hacking toolkit Kali Linux. Another method involves storing the code directly in the web server's database known as stored XSS. Hackers often aim for this using XSS as a means to an end. Many major hacking incidents have involved this technique. For instance, suppose there's a forum where users can submit posts, typically including titles and content. Since content can contain a lot of text, it's easier to inject malicious scripts there. Now, imagine inserting the previously mentioned malicious code into either the post title or content. As a result, when users browse the forum and come across these posts, they'll see the malicious code in the title. This means the code has already reached their browsers and possibly executed. If it's in the content, just viewing the post triggers the code. In such cases, the post title's impact is significant. Even just browsing through the list of posts can lead to downloading the malicious code. Some search engines even include titles in their search results, which is terrifying. It means simply viewing the search results could lead to infection. So, while reflective XSS requires sending emails to specific individuals, stored XSS lets people voluntarily download and execute the malicious code, making it far more dangerous. Imagine the potential damage if the hacker's equipment receives numerous session IDs, especially if one of them belongs to an administrator. However, identifying the administrator's session ID among many others might be a challenge. Due to its widespread impact, stored XSS is considered one of the most practical hacking techniques among hackers, alongside SQL injection. Now, let's take a look at how it's actually done. I highly recommend trying it out yourself. Experiencing it firsthand will give you a different perspective than just reading about it.
Should I register a new game item now? This is a very suitable place to insert hacking codes. You can insert the XSS hacking code here. Remember when we hacked with SQL map? If you check the structure of the item box table, then you can find out that you can store the most letters in the product column. The length of the XSS code is quite long, so the product column would be suitable for attacking. Let's see if the newly registered game item is searched. If the administrator does not approve it, it can be searched. Even if you put the highest price, it's just not visible on the website. You can see that our newly registered game item is stored in the item box. Let's get ready to receive the administrator's session ID on the hacker machine. In fact, you can get the session ID of everyone who visits the search page, but all we need is the manager's. Let's find out the IP address of the administrator machine. Let's also find out the IP address of the web server. Now, the administrator machine will automatically access the web server and search for game items. This is the fun part, because the Python code automatically mimics the manager's behavior. It shows the scene where the administrator machine accesses the web server and searches for game items. The manager machine finally touched the infected area of the XSS code. It's the game item that we inserted the XSS code earlier. I think something came into the hacker machine's port 8237, probably the session ID of the administrator who accessed the search page. If you look at the contents of the XSS hacking code we used, the session ID is supposed to be sent to port 8237 of the hacker machine. I can see session ID. If you use the proxy server on the hacker machine, you can force this session ID to insert when sending and receiving packets. Then, the web server recognizes us as managers. However, it is possible only while the actual administrator is accessing. If the connection is lost, the session ID will lose its effect. It's the packet manipulation function of Burp Suite, because we have to automatically insert the administrator's session ID into the packet every time we access it. As you can see now, insert the session ID into the cookie part of the request packet. This is a scene where the packet was actually caught and fixed. Let's access the website using the session ID of the manager we stole. The session ID we stole is PHP-SES ID. Now, you'll see that you're logged in as an administrator. Werewolf. Then we can now enter the manager page. We are finally on the admin page. You can delete or approve the game item here. Approval means that information on game items can be exposed on the website. Then, should I delete any game item? You will see an administrator trying to send a session ID and a lot of information to delete game items. It's been deleted. Then let's go back to the manager's page and check. Yes, it's gone.
Actually, if web servers effectively filter out these malicious codes in the background, there wouldn't be a big issue. To be honest, with just a few filtering functions, you can almost perfectly prevent such attacks. However, implementing this level of security across all pages is not easy. In modern times, frameworks are often used to apply filtering at specific layers. But even with frameworks, there will come a time when separate pages are created that don't adhere to the framework's rules. Frameworks can't cover every scenario. Whether it's a test page or a permanent one, these specially crafted pages often have vulnerabilities, sometimes due to being rushed or forgotten about later. The worst-case scenario is leaving these pages behind after testing. You might think it's safe because the URL isn't known, but hackers are persistent. The scary thing about XSS is that there are many tools available to quickly and easily find security holes in these pages. Moreover, such scanning doesn't require a large volume of packets. Unlike tools like SQL Map, which send out numerous queries to obtain one or two answers, these tools simply check whether certain tags like script or img can be stored. Even if caught, someone might dismiss it as a mistake. Due to infrequent attempts, even if intrusion detection logs catch something, it might not attract the administrator's attention. Alternatively, intelligent crackers might deliberately create confusion by scanning with temporary accounts, generating a lot of noise, and then take advantage of the distraction. Therefore, the best approach is to use an absolute whitelist to only accept pure strings. Allowing exceptions for certain tags always carries risks. Of course, the stronger the whitelist, the more minor tasks developers must handle in the background. Finding the most ideal whitelist while reducing such burdens is what a security expert should do. Naturally, all pages where user input is possible should be filtered and scanned. In simple terms, any page involving SQL's insert should be filtered. Front-end security measures can be bypassed through proxies, so all security checks should be done on the server side. If specific elements need to be filtered out, one good approach is to always remove the script tag. Since JavaScript is a programming language, it always requires its own area, hence the necessity of the script tag. Then, additionally, block well-known tags like img. If you need to add an image, unfortunately, you'll have to allow it, but in that case, ensure users can only input the file name of the desired image within completed sentences. It's like using prepared statements to prevent altering fixed SQL statements. However, still, the whitelist approach is the best defense because there are countless combinations of XSS codes out there. If you have time, search for XSS cheat sheet on the internet and you'll see what I mean. You can use incredibly imaginative combinations of code. Since hacking involves unconventional actions, it's best not to provide any opportunity for weird behavior. That's why a whitelist approach is the best when filtering.